Hello, I am Viraj, and when the term cellular bioelectricity is evoked, it often brings forward the picture of a neuron in the mind. But what we often forget is that most cells, if not all, have the required machinery like the ion pumps and the gap junctions and ion channels to maintain a transmembrane potential. What we do observe is that relatively hyperpolarized cells like muscles and neurons that maintain the membrane potential around minus 70 to minus 90 millivolts rarely, if ever, replicate. On the other hand, we have epithelial cells that are relatively depolarized, things like hematopoietic stem cells, around minus 30 millivolts that show rapid replication. A question worth asking is that is this merely an artifact, or does the arrow of causality flow bidirectionally? Well, turns out it does. When exposed to prolonged depolarization, even neurons go through mitosis. And when exposed to hyperpolarization, rapidly proliferating cells, like Chinese hamster ovary cells, are subjected to a complete but reversible mitotic block. I believe bioelectricity, partly due to its ability to control mitotic activity, is what gives us fascinating results. Some of the examples that you might have seen out of my former mentor, Dr. Levin's lab, are inducing an eye on tail of the frog, inducing limb regeneration in species that do not inherently regenerate. And I believe bioelectricity as a modality could shed a lot of light on interesting mechanisms, both for self-assembly, regeneration, and developmental biology, and give us interesting tools to combat degenerative diseases. If this is something that sounds interesting to you, please come find me. Thank you.